In this chapter, we're going to be talking about stress and the trauma-related disorders that can result from severe stress. We will be covering several topics within this chapter, including the general adaptation syndrome, which is the basis of understanding stress. We will define the stress response and the systems of the body that are associated with it. We'll look at the relationship of stress to cardiovascular disease and to immune function. And then finally, we'll talk about trauma responses, such as the post-traumatic stress disorder and how that's treated. You might be surprised to learn that the word stress was borrowed from engineering and referred to the strain on an engineering structure that could in time lead to failure of that structure. We think of stress as being a psychological term, and always has been. The general adaptation syndrome, identified by Hans Selye, hypothesized that when we're faced with a stressor, we respond with an initial alarm, but then very quickly our body adapts and we perform not only at the level we had been, but at a higher level. That is, until we run out of energy and we get into a third stage called exhaustion. So in our discussion of stress, we're going to look at the stressors and the stress responses separately. This slide illustrates a general adaptation syndrome, the three phases: alarm, resistance, and exhaustion. Note that when a stressor hits us, initially it catches us by surprise, and at least initially our performance goes down, but very quickly we react and in fact perform at a higher level until we run out of energy. And during the exhaustion phase, which may feel like exhaustion or may feel like depression, we're simply not able to handle the stress any longer. You may remember from our earlier discussion that the autonomic nervous system is involved in our stress response. The autonomic nervous system has two divisions, the sympathetic and the parasympathetic nervous systems. They tend to be mutually inhibitory. When we are not stressed, the parasympathetic nervous system is active and it basically takes care of the general health of our body. When we are stressed, all of our energy goes into dealing with that stress response, and the sympathetic nervous system is active. Again, they tend to be mutually inhibitory, so when one is active, the other tends to be inactive. When the sympathetic nervous system is active, it usually will trigger the endocrine system. The endocrine system is designed to work together with the sympathetic nervous system. The sympathetic nervous system gives us a fast response to a stressor. What the endocrine system does is uses a biochemical boost to keep us in a resistance phase for as long as possible. That boost is done through hormones that are produced by glands and dumped into the bloodstream. The hormones that are particularly important here are epinephrine, norepinephrine, and cortisol. We're going to be talking mostly about cortisol because it's one of the easier hormones to measure and one of the most important in the stress response. The parasympathetic nervous system is often overlooked, and it's very important to our survival. I always describe the parasympathetic nervous system as controlling the housekeeping chores of the body. Things like digesting food, removing waste, things that keep us healthy. One aspect of stress is that if the stress is prolonged, if it is around too often, we have too much sympathetic nervous system activity and therefore too little parasympathetic nervous system activity. And consequently, the housekeeping chores of the body, which keep us healthy, may take a beating, and we're likely to experience some sort of physical problems as a result. We'll talk more about that later. This illustrates the mechanisms for the stress response. Primarily sympathetic nervous system activity, typically triggered by the hypothalamus, and what we call the HPA axis response, which triggers a variety of hormones. The hypothalamus is what regulates the autonomic nervous system. Specifically, the posterior portion of the hypothalamus activates the sympathetic nervous system, whereas the anterior or front portion activates the parasympathetic nervous system. As I mentioned, they tend to be reciprocal inhibition in that one tends to reduce the activity of the other. Particularly for the parasympathetic nervous system, the goal is to maintain a homeostatic condition in which the body is well regulated and functioning. And it does that by taking care of the housekeeping chores. I'm sure none of you are surprised to learn that people vary in terms of their reaction to stress. And a lot of things contribute to how people will react. A specific situation might, in some contexts, create a strong stress response, and in other contexts, not a particularly strong stress response. Of course, the intensity and the frequency of stressors has an impact. We've all had days where we lost it, not so much because we were under an enormous stress, but it was like one thing after another. The frequency seemed to gang up on us. Predictability and control is very important. We're going to talk about that in just a moment. And of course, when we're talking about really intense stressors, there's often a long-term effect of that. We call that trauma, and we will talk about trauma disorders at the end of this chapter. I mentioned earlier that predictability and control is very important, and in a moment I'm going to tell you about a formal research design that has been used mostly with animal models, but to a degree with human subjects as well. But before I do that, I want to talk about another line of research that looks at predictability and control, and frankly, this is a tough area to talk about. There are countries that routinely use torture as part of their functioning. They will torture confessions out of common thieves, but they typically will use their greatest level of torture for political prisoners, people that disagree with the government and fight against the government. Interviews with these political prisoners who survived but were severely tortured suggest that they all seem to pick up a sense of controlling the situation so that they feel less stress. Now, they can't control the situation by not being tortured because, well, that's just what happens to political prisoners in these countries. So instead, what they do is they provoke the person who's torturing them so that that person starts the torture earlier and makes it more intense, which seems on the surface like that's counterproductive. That's making it worse on yourself. But by controlling when and how intensely they make it, even if it makes it worse physically, it seems to make it better psychologically. The long-term stress response is alleviated to a degree by exercising this level of control. Now, we've studied that experimentally with animals and also to a degree with human beings in what's called the triadic design. I'll show it to you in just a minute. We have a group of subjects, we'll call them experimental subjects, who receive stress. Sometimes they have the ability to avoid the stress or to shut it off. We have yoked subjects who experience exactly the same amount of stress at the same timing, but they don't have control over it, and they can't predict it. And then we have control subjects who are not stressed. So here is the design that I just described. Now, no one would be surprised that if you do not experience stress, you don't have much of a stress response. The control subjects simply illustrate that. And that if you do experience the situation, the stress, you are going to experience a stress response proportional to the degree of stress. But what is very clear is that if you know when the stress is coming, which means predictability, or you have the ability to escape the stressor once it comes, that's control. The same stressor has much less effect. So the yoke subjects whose stress is exactly the same as the experimental subjects, but they lack either predictability or control, they experience much more severe stress response. This slide illustrates an importance of control in how you experience a stressor. If you're absolutely sure you can handle the stressor, you may actually find the stress exciting. Skilled skydivers, for example, love jumping out of planes because they know they can handle it. They know that if something goes wrong, they'll handle it just fine. If you've only jumped out of planes once, you might have some doubt of whether you can handle it, although I hope you never jump out of a plane without a fair amount of confidence that you could handle a problem if it came up. In that case, you would experience stress. If you're in doubt whether you can handle a situation, it might be something like jumping out of a plane, or it might be a new job, you're going to experience not just stress, but anxiety. Anxiety is this doubt about whether you can handle it. And if you're pretty sure you can't handle it, you're going to experience depression. So the same stimulus, depending upon your level of control, can lead to everything from excitement to the downs of depression, where you feel like it's a hopeless situation for you. We've talked about the physiological mechanisms of stress. I want to pull that together into the entire system, from stressor to reaction to shutting down the stress response. The first line of defense is the sympathetic nervous system, which gets its signal from the central nervous system, which is constantly monitoring the environment. The sympathetic nervous system reacts quickly in a matter of fractions of a second to prepare our body to deal with a stressful situation. In general, the sympathetic nervous system will trigger the HPA axis, which releases the stress hormones, primarily cortisol. Stressors usually come and go, so when the stress is gone, we want to shut down that response. We do that with a limbic system organ called the hippocampus, which is part of the brain. Unfortunately, one of the problems with cortisol as a stress hormone is that it slowly damages the hippocampus, which is the off switch for the stress response. So if you experience too much stress over too long a period of time, your stress response works fine, it just doesn't have much of an off switch anymore. So it doesn't go away. We see that in post-traumatic stress disorder and in various stages of dementia as well. We're going to talk about both of those later on in the course, PTSD in this chapter, dementia much later.